Now we are discussing very important topic of trigonometry. It is trigonometric identities. These are identities because these things are valid. These relations or these equations are valid in all circumstances. Therefore, these are identities. The three identities which are very important identities are, one is cos square theta or cos square a plus sin square a is equal to 1. The second one is 1 plus tan square a is equal to secant square a, and the third one is 1 plus cot square a is equal to cosec square a or cosecant square a, right? These are the three identities very useful in trigonometry in finding out relations or establishing other relations, right? Now these three proofs of these three are very similar. Let us prove the first one, that is to prove cos square a plus sin square a is equal to 1. It's easy. I'm taking out diagrams directly from textbook. This is ABC, right? And you are speaking about angle A. Once you fix the angle, always it is opposite, and this is adjacent. Hypotenuse is AC, opposite to 90 degrees. From triangle ABC, angle B is equal to 90 degrees implies a Pythagoras theorem, AC square is equal to AB square plus BC square. Call it the equation 1. Right? Now, from triangle ABC, what is sin A? Sin A is the opposite by hypotenuse, and opposite is BC, and hypotenuse is AC. And what is cos A? Adjacent. This is adjacent AB by hypotenuse AC. Now start with the LHS of the identity. What is LHS? Cos square A plus sin square A. Cos A is AB by AC whole square, sin A BC by AC whole square. And this is equal to AB square by AC square, BC square by AC square, and AC square is taken as LCM. You get AB square plus BC square. But AB square plus BC square, you can see this is equal to AC square. Therefore, AC square by AC square from equation 1. This is equation 1. Right? And you can cancel these two. Is equal to 1. And that is what you have to prove, RHS. And therefore, cos square A plus sin square A is equal to 1. You remember it like this only. Generally, some of the teachers say sin square plus cos square is equal to 1. But here we say cos square plus sin square is equal to 1. Why we put cos square before sin square? Because this relation, if you remember like this, when you go and learn hyperbolic trigonometric functions, then cos comes first and sin comes later on. In between you get minus cos h square a minus sin h square a. For that sake, here better you remember it like cos square a plus sin square a is equal to 1. This is how you can prove the first identity. How do you prove the second identity? To prove the second identity, same, you draw the same triangle again. Same. and you see this is opposite as it is adjacent, and this is 90 degrees. To prove 1 plus tan square A is equal to secant square A, to prove this, what would you first find? First, from triangle ABC, angle B is equal to 90 degrees, and therefore AC square is equal to AB square plus BC square, same as in the previous proof. Now you should find tan and you should find secant. From triangle ABC, what is tan A? Tan A is opposite by adjacent, that is BC by AB. And what is secant A? Secant A is just reciprocal of cos A, and cos A adjacent by hypotenuse, and therefore secant A is a hypotenuse by adjacent, that is AC by AB. Now what is LHS? 1 plus tan square A. What is tan A? BC by AB. So simply substitute the value. This you get BC square by AB square. And this is equal to, take LCM, AB square. You get AB square plus BC square, and plus AB square plus BC square again is AC square. So AC square by AB square we write as AC by AB whole square. But what is E by AB? Secant A. So secant square A. Therefore 1 plus tan square A is secant square A. Here there is one very important note. Generally this is this I will write as a note here, not in the regular thing. Here we write AC by AB whole square is you can write like secant A whole square. Secant A whole square is not secant A square. That is very important. This is not A square. You are squaring the ratio secant. So we write ratio square, not A square. This is not angle square. This is ratio square. So secant square is ratio, square on the ratio, AC by AB. So this you must very carefully remember. Like square on the ratio is sine square, cos square, because sine is the ratio, not angle square, right? So this is how we prove the second identity. And the third identity is 1 plus cot square A is cosecant square A. This again is proved similarly as it is almost. Just to find the values, you get A, B, C. This is the angle you are speaking about. This is opposite side and this is adjacent side. So this is 90 degrees. So from triangle ABC, angle B is equal to 90 degrees implies AC square is equal to AB square plus BC square. Then what would you do? Again same, you must find cot A. From triangle ABC, find cot A. Cot A is equal to, tan A is opposite by adjacent. Therefore, cot A will be adjacent by opposite. So, AB by BC. And what is cosecant A? Cosecant A is reciprocal of sine A. Sine is opposite by hypotenuse. So, cosecant will be hypotenuse by opposite, or AC by AB. Now, let us start with LHS again, like 1 plus cot square A, 1 plus AB by BC whole square is 1 plus AB square by BC square is equal to, take BC square LCM, BC square plus AB square. BC square plus AB square is AC square. So AC square by BC square, otherwise AC by BC whole square, and AC by BC is equal to cosecant I should get. I am wrong somewhere, right? AC by BC is cosecant. This is wrong here. AC by BC. So this is AC by BC square is equal to cosecant square here, right? Because cosecant is a hypotenuse by opposite, and opposite is BC, hypotenuse is AC, and therefore cosecant is this. Therefore 1 plus cot square A is equal to cosecant square A. These are the three identities which we have proved. In the next video, we will try to learn some applications of these identities. Thank you.